So now that we know the basics, what we're going to do here is we're going to wind up using some of our algebra skills we learned in section 6.1 to find a missing piece from these formulas, okay? So like this time, you won't just be looking for the interest, or you won't be looking for the future value. You might be looking for what's the time it would take, or what's the interest rate, or how much would you have to deposit, okay? So on question number 5, we know this company invested, so they deposited this much money for this many years, and we know how much interest as well. So try to identify what you've got. You've got the P, you've got the T, and you've got the interest. So I'm being asked to figure out what the interest rate was for this. So normally we're given that, but this time they're kind of switching it around. So do you notice how you've got the P, the T, the I, but you need the R? So this formula, so we know we could use I equals PRT because we have 3 of those 4 variables given to us, okay? All right, so we're going to plug in. So we know okay, let me put it over here. I equals PRT. So we're going to plug into the appropriate spots. The P would go there. I don't know the R, so I'm going to leave it an R. The time was 10, and the interest was 9,150, so it actually goes there. So we have this equation. It's a linear equation. So now we're going back to like 6.1. So I'm going to go ahead. If I have multiplication, I can go ahead and rearrange things and do 10 times that 15,250. So I'm going to put this and go ahead and multiply times 10 and get 152,500 times R. Okay. So let me go up here. Sometimes we do better if our unknown is on the left. So I'm going to go ahead and switch the 2 sides. That's okay to do. And then what I need to do is get R by itself. And since between these two, there's understood multiplication in there, I can do that by dividing both sides by 152,500. All right, and when I do that, I wind up with the R equaling, and then that 9,150 divided by that, I want it to be as a decimal, so you'll have to make sure if you get fractions on your calculator, so you know how to switch it to a decimal. Turns out to be 0.06, and then that is equal to 6%, and so that would be my answer. Okay? All right, now, I could have one little thing I want to tell you, is that instead of multiplying the 15,250 and the 10, I could have gone ahead and divided by both. I could have divided the 9,150 by the 15,250 and by the 10. Okay. I'm not even going to write that. I think this is a better way to do it. All right, now let's look at what we got here. All right, so here we have the R. We know R equals 0.06. Okay, we want to know what lump sum must be deposited now. So that's the P, right? Present value, what you're depositing now is your P, so that its value will be this. So this right here is going to be the A, and that's our time. So I need some formula that involves R, P, A, and T, and that's why I'm going to grab this one. So A equals principal, and then times the quantity, 1 plus RT. So that 3,500, this is one of the harder types. The 3,500 doesn't go in for the principal. It's the future amount. It's what you want in your account at the end of those 2 years, okay? So we're looking for the principal. We don't know that. and our interest rate was 6%, so I'm putting in 0.06, time was 2 years. Okay, so it's actually, this is something that people might actually want to know, because this would be the idea behind, okay, what would I have to deposit today so that in 2 years, in an account with 6% simple interest, I would have the $3,500 that I'm trying to save up for a vacation. So what would I have to deposit today? So 2 years from now, I would have $3,500, which is my goal for something. Maybe it's a vacation or a used car or a sofa or something like that. All right, so what we can do here is we can clean this up. If you do 1 plus the 0.06 times 2, okay, that's going to be 1.12. So on this right-hand side, we have 1.12 times P. All right, so we're really trying to get what P is. All right, so right now we have 1.12 P equals the 3,500. And since that's times right there, aren't we going to divide by the 1.12 on both sides? And then that's going to wind up giving us the principal. And on that one, when we do that, we get $3,125. So we would have to put $3,125 in this account that has a 6% simple interest rate. We'd have to leave it there for 2 years in order for it to grow to be $3,500 at the end. So do you see on these problems, take a moment to identify what you have and what you're trying to find. So if you have these letters, then that's the interest equal principal times rate times time formula, right? But if I've got the R, the T, the P, and the A, then I'm going to want to use this one to find the unknown, the missing piece. So on this one, our missing piece was the principal, was what we're looking for. And then on number 5, what we were looking for was the interest rate. We were given the other 3 quantities. Okay. All right, let's do another one. All right, now this one is actually something more similar to what I might do. So here, this person's trying to buy furniture that costs $4,000. She's going to save up for it. So she's putting $2,500 in an account now, has an interest rate of 8.75% simple interest, and she just wants to know how long is it going to take for her to reach her goal. That means without her putting any more money in, you know, just the $2,500. She's not adding anything to it over time. Okay, so let's go through this. So she's depositing $2,500, so that's the P. Okay. All right, so that's her P. All right, simple interest rate 8.75. The question is, how long will it take her to reach her goal? So that's going to be the T. And this $4,000 is what she's trying to save, what she's trying to have at the end, right? So that's actually the future value or future amount. So this one is also one where you would start with the A equaling P times the quantity, 1 plus RT. The principal is $2,500. The interest rate, 8.75%, 8.75%, if I move the decimal 2 places, would be 0.0875. So 0.0875. Don't forget that 0 right there. And it's times that T, but I don't know what the T is. And we know at the end we want it to be 4,000. Okay? All right, so for this one, what you have here, trying to decide the best way to tell you to do this one. You have options about how to approach it. If you know your algebra, you could divide by that $2,500, and that would get you closer to getting that t by itself. But I think perhaps a more intuitive way to do it, based on how we've been solving equations, is to distribute the 2,500. All right, so if we did that, then we would get the 2,500 times the 1 plus the 2,500 times the 0.0875 times the t. And then I'm going to also switch these two sides around, because that's always okay, so that our unknown is on the left. Okay, so all I did was switch those two sides. I don't want that to look like division, so I'm going to erase that on each side. There we go. Okay, so I just switched the two sides because I can, and the variable I wanted it over here on the left. All right, now you got to be careful when you're looking at this and not misinterpret what you can do next. First thing we'd have to do here, or a couple things we could do here, would be to go ahead and multiply those two together. So let's take that 2,500 and multiply it by the 0.0875 just to clean that up a little bit. So that would be 218.75 t. All right, and then I'm just going to bring down the rest of the problem that I already had. Okay, and there you have it. Now it looks more like that question number 1 that we were solving when we were solving equations. It's just the numbers are bigger, but the process is identical. So first thing we're going to do is take away, at this point, is to take away the 2,500 from both sides. All right, now when we do that, we wind up with the 218.75 t is now going to just equal 1,500 over here. All right, I'm taking the 4,000 and subtracting 2,500, that's going to be 1,500. And then this was times right here. So to get rid of it, we're going to divide. Do that on both sides. And what we're left with is t equaling, and let me do that, see what it turns out to be. 75 turns out to be about, it goes on, 6.857142857. You know, it goes on for a while. So you might round and watch it if it specifies. I didn't really specify. So if we round to the nearest hundredth, it's not dollars here, it's years. That would be like 6.86 years, or we might just say about 7 years. So it's going to take her about 7 years to save up if she doesn't add any additional money to that account.